Listen up, Neet aspirants. Today we are tackling a classic trap that the NTA loves to set in the units and dimensions chapter. Usually, if a physical quantity has a unit, it has a dimension. But there is a massive exception to this rule, the supplementary quantities. Let us break them down. First, we have the plane angle, represented by d theta. Imagine a circle. The plane angle is simply the ratio of the arc length ds to the radius r. So d theta equals ds over r. Its SI unit is the radian. Next, step into 3 dimensions with the solid angle represented by d omega. Imagine a sphere. The solid angle is the ratio of the intercepted surface area dA to the square of the radius r square. So d omega equals dA over r square. Its SI unit is the steradian. Now, here is the high yield secret. Look at the formulas. Plane angle is length divided by length. Solid angle is area divided by area. The dimensions completely cancel out. This means their dimensional formula is exactly M0, L0, T0. They are utterly dimensionless. Memorize this rule right now. A physical quantity can have units but no dimensions. The plane angle and solid angle are your prime examples. But remember, the reverse is never true. Pro tip for your numericals: to convert degrees to radians, remember that 1 degree equals pi over 180 radians. And if you ever see a trig function without a degree symbol like sine of 15, you must assume that 15 is in radians.
Now let's solve some neat MCQs and PYQs related to this concept. Let us look at question 1, a classic direct hit from the NTA in the year 2022. The question asks, plane angle and solid angle have what? Option 1, both units and dimensions. Option 2, units but no dimensions. Option 3, dimensions but no units. Option 4, no units and no dimensions. Let us run a quick concept check. First, do they have units? Yes, the plane angle is measured in radians and the solid angle is measured in steradians. Next, do they have dimensions? As we just learned, both are ratios of similar quantities, length divided by length and area divided by area. This means that dimensions cancel out entirely, leaving us with exactly M0, L0, T0. They are dimensionless. Therefore, they possess units but no dimensions. The correct choice is option 2. Mark it and secure your +4 marks.
Moving on to question 2. This is a recent direct hit from the NTA in Neet 2024. The question asks, the quantities which have the same dimensions as those of solid angle are: option 1, stress and angle; option 2, strain and arc; option 3, angular speed and stress; option 4, strain and angle. Let us run our concept check. We already know our target. The solid angle is completely dimensionless. So we are hunting for the option where both quantities have dimensions of M0, L0, T0. Let us jump straight to checking option 4. First, strain. Strain is the ratio of the change in a dimension to its original dimension, such as change in length over original length. Length divided by length cancels out. It is dimensionless. Second, plane angle. As we learned earlier, it is the ratio of arc length to radius. Again, length over length, also dimensionless. Because both strain and angle are perfectly dimensionless ratios, they share the exact same dimensions as the solid angle. Therefore, option 4 is your correct answer. Secure those +4 marks.
Question 3 takes our knowledge of the solid angle and perfectly blends it with electrostatics. This is a very common profile in top mock tests. The question reads, a point charge Q is placed on the axis of a disk. The disk subtends a cone of half angle 45 degrees. What is the electric flux passing through the disk? Let us break this down. First, we need to calculate the solid angle, omega, subtended by the disk at the charge. The mathematical formula for a cone's solid angle is 2 pi times 1 minus cosine theta. Substituting our half angle of 45 degrees and simplifying the math, our solid angle omega becomes square root of 2 times pi times the square root of 2 minus 1. Now apply Gauss's law. A charge Q radiates a total flux of Q over epsilon 0 across a full 3D sphere of 4 pi steradians. To find the flux through just our disk, we multiply total flux by the ratio of our solid angle to 4 pi. Substituting our calculated omega into this formula, the pi cancels out and we are left with the final flux equal to square root of 2 times square root of 2 minus 1 times Q, all divided by 4 epsilon 0.
Question 4 tests a high-yield mock paper concept, the dimensionality constraint of arguments. The question gives us a wave equation, y equals O sine of AET minus BVX. It asks for the dimensional formula of the ratio A over B. Here is the golden rule. The argument of any trigonometric function like sine or cosine must be completely dimensionless. This means the term AET has no dimensions. So the dimension of A equals 1 over the dimensions of energy times time. Energy is m L square T minus 2, time is T. Calculating this gives us m minus 1 L minus 2 T1 for A. Similarly, the term BVX is also dimensionless. The dimension of B equals 1 over the dimensions of velocity times distance. Velocity is L T minus 1, distance is L. This gives us L minus 2 T1 for B. Now simply divide A by B. Notice how the L minus 2 and T1 terms cancel out perfectly between the numerator and denominator. We are left with exactly m minus 1 L0 T0. Match this with our choices and option 3 is correct. Mark it and let us move on.
Welcome to question 5, the final question of this set, testing your pure NCERT taxonomy knowledge. The question asks, which of the following is correct regarding the classification of plane angle and solid angle in the SI system? Option 1, base units. Option 2, derived units. Option 3, supplementary units, which are dimensionless but possess unique SI units. Option 4, improper units. Let us do a final concept check. The SI system officially designates exactly 7 base units like meters and kilograms. Because angles are dimensionless ratios of length over length or area over area, they cannot be pure base units. However, because they are so fundamentally unique, they were placed in their own special category, the supplementary units. This category explicitly acknowledges our golden rule from today. They are totally dimensionless, yet they possess the unique official SI units of radians and steradians. Therefore, option 3 is the exact correct NCERT definition. Congratulations on mastering this high-yield trap.
Visit neetapp.in or download Neet app for more chapter-wise or concept-wise CBT-based MCQ solving. Subscribe, share and like the video. See you in the next concept video.